So last week you guys learned how to factor with GCF.
Yeah.
You find the greatest common factor, you divide it out into the front. Okay? Today we're going to learn another way to factor. It's difference of two squares. A lot of times I call this one dots. So if you want to write dots at the top, dot stands for difference of two squares. These words right here, difference of two squares. So we have GCF, we have dots, and then we'll learn factoring trinomials on Wednesday. Okay, so by the end of this week, you'll have 3 methods for factoring. Any questions so far?
No.
All right, so here is a quick review of how these multiply out. So when you multiply these, you double distribute. Does everyone remember that?
Yes.
Okay, so we have x times x, that's how we got the x squared. Then we have x times positive 4, that's the plus 4. Then we distribute the minus 4, so minus 4x and minus 16. What always happens in the middle?
They cancel.
They go away. And we're left with this. A minus sign in the middle and 2 perfect squares. There's a number squared that gives you x squared, it's x. There's a number squared that gives you the 16, and it's 4. Okay? Everyone recalling this information?
Yes.
Here's another one. So when I double distribute here, I would get a squared plus 7ay minus 7ay minus 49y squared. What happens to the middle terms? Again, they cancel out. You're left with a perfect square minus another perfect square.
Technically, it's 2 perfect squares, but no.
I think he's referring to back here. It's a coefficient and a variable, but it's one term. So. All right, any questions so far? This should be a review. Sounding familiar?
Yes.
Okay, so without even writing out, what do you think we're going to end up with here?
Yeah.
16 minus 9m squared, okay? So here's the work. You end up with a negative or a minus 12m plus 12m. They're going to go away, and we end up with those difference of squares that we just discussed.
Do you have to flip? Like you can flip the order?
No, you cannot flip the order. Nope.
I thought the variable got to go in the front.
Right. That's what the teacher said.
The variable typically goes in the front. A difference of two squares is kind of different because it depends which one has the opposite signs. All right, so that should all be a review. Now we're going to talk about what it means to be a perfect square. So is 4 a perfect square?
Yes.
Yes. Is 8 a perfect square? No. There is not a number multiplied by itself that would give us an 8. Is 100 a perfect square?
Yes.
Yes. Is x squared a perfect square?
Yes.
Yes. It would be x times x. Is a to the third?
No.
No. It has to be an even numbered exponent. So, here's kind of a tricky one. Y to the 4th.
Yes.
It is, and it'd be y squared times y squared. Good. Or y squared squared.
Yeah.
So it doesn't matter what even number it is, it'll be.
All even exponents are perfect squares, yes. All right. What are your questions? What about this one? No. That's a no. It's not even. It's a 49 itself is a perfect square, but x to the 49th is not.
Because you can do 7 times 7.
Right. All right. So here is the things we're going to look for. Okay. What does the difference of two squares look for? Well, just what it says. Difference. Difference means a subtraction sign. Okay. It has to be a difference. You also have to have two terms that are both perfect squares? All right, here's our first example. Can we put the movie snacks away till later on? I realize this is super entertaining, but not quite like a movie theater. All right, so what am I looking at here?
A perfect square. Sorry.
Two perfect squares. Does it have a minus sign? Yeah, so this is a dots. Now, we need to figure out what times itself gives you x squared.
No.
X and x, right? What number times itself gives you 25? 5. So I can break this one down into x and x. I can break this one down into 5 and 5. Now I'm going to write these in binomials. All right, so one of these goes here, one of these goes here. And then we have to have same idea, but with a negative. Now, you could write it x minus 5 times x plus 5. That would be the same thing, okay? Whatever number times itself gives you the first term, that goes in the front. Whatever number times itself gives you the last term, that goes in the back. One gets a plus sign, one gets a minus sign. What are your questions? Okay, here's our next one. What number times itself gives you 121? 11. So I can break that down into 11 and 11. What number times itself gives you a squared? A and a. Good. All right. So what is my answer going to look like?
11 plus A.
Keep it in the order that it's in. 11 plus A. 11 minus A. Don't flip-flop the order. I know it's tempting, but we need the minus to be with the A. All right? If you flip-flop them, meaning if you put like the A here and the 11 here, all these signs would be backwards. We don't want to do that. All right. It's getting a little trickier.
Okay, the numbers
Are they perfect squares? Is there a minus sign?
No.
Yeah, so I'm ready to roll. I just got to figure out what number times itself gives you 16.
That's 4.
So 4 and then x, good.
5y squared.
And then, yep, 5y squared, good. Just divide the exponent in half, and they each get that. So this would be 4x.
Is this going to be harder?
Not really. This is the easiest way to factor. So yeah, we'll have 4x plus 5y squared, 4x minus 5y squared.
So does that mean that it's not a perfect square if it's an addition sign instead?
Right. If it's a plus sign, it would be a sum of two squares, which is not a thing. All right, so here's part D. Yes, we have two perfect squares. We have a minus sign in the middle. What's going to happen in the front? 9a and 9a. Good. What happens in the back? 4y, 4y. Good. Then what?
9A plus 4Y. 9A minus 4Y.
Very good. 9a plus 4y, 9a minus 4y. Questions? Ah, I knew that was coming.
No.
Why do you
Yes,
say
they
no?
are. No.
They are, yeah. Just check out the numerator and the denominator separately. 1 is a perfect square, 9 is a perfect square, 4 is a perfect square, 25 is a perfect square, r squared is, t squared is. So how would you break up the 1/9? 1/3 and 1/3, and then you just tack on the r because it's r squared, okay? What about the 4/25ths? 2/5, good, and then just keep the t with it. All right, now what? 1/3 r plus 2/5 t. Very good. Questions?
Who got some legs?
What type?
I don't know. I got all.
All right, is this a difference of 2 squares?
0.7. You got 0.7.
I'm sorry, I'm getting a little sidetracked. What? Is this a difference of 2 squares? Yes. What is it?
8y squared.
Yeah, so we have 8y squared and 8y squared. 5t, 5t. So it's going to be 8y squared plus 5t.
8y squared. 5z squared. 8y squared. Minus y.
Very good.
Good job, Victoria.
Mm-hmm.
Man, I get told.
All right, questions.
I'm not sure I
Oh
understand.
my gosh.
Right.
She loves math class. All right. I know, it's going to be awesome. All right. Are these perfect squares?
No.
You got some for this one?
0.9.
Yeah, I guess.
No, I ain't got none. Oh yeah, I got 0.7.
Does anyone have any ideas?
No.
I have an idea.
Yes.
Please don't let
You can go ahead.
Are these perfect squares?
No.
No.
Okay, what's the other way we know how to factor?
Write down all the factoring thingies.
Okay,
Or just find factors.
okay, okay.
The greatest common factor is
What is the greatest common factor?
4.
Uh,
3.
Well, then it must be 3.
it's actually 3, yeah. Okay, so you can do both factoring methods in the same problem. Anytime that's an option, you go GCF first. So these are not perfect squares. However, they do have a common factor of 3. So you can divide a 3 out of each term. So now you're going to write it with a 3 in the front. What would you have left over in the first term? 25x squared minus 4. Do those numbers sound a little better? Yeah, those are perfect squares. So now we can factor what's in parentheses again, leaving the 3 out front. So we still have the 3. What happens back here?
5x and 5x.
5x and 5x.
2 and 2.
2 and 2. Good. So leaving the 3 in the front, what would my answer be?
5x
5x plus 2, 5x minus 2. Perfect. Questions?
Wait, don't change, because I'm just going like this.
Okay. All right. Oh, sorry.